Hello. Okay, so we are going through topic 3, which is on rationalizing denominators, which is actually just like radical division. A couple of rules about what is a simplified radical expression. The first thing is no more factors can come out. So like if you had the square root of 20 or 50, not considered simplified because we can take that 25 out. You have no more fractions in the radicand. So we want to make sure we're simplifying our fractions out. And then the real star of today is we cannot have any more radicals in the denominator. And we'll kind of look at what that looks like. To begin with, first we're just going to divide with radicals. We did a little bit of this before. Reminder, when you divide with a radical, if you have a fraction with a radical, it just means that both the top and the bottom get it. So we can look at this rule both ways. So when you look at the first one, the square root of 18 over the square root of 2. We can instead think of this as one big fraction, 18 divided by 2, which is helpful because if instead of doing the radicals first, we do the fraction first, 18 divided by 2 is 9. What's the square root of 9? 3. So again, if you have a fraction with a radical, you can reduce the fraction first. So like 50 over 18. Well, it doesn't reduce perfectly, but if I divide these both by 2, so divide by 2, I get 25 over 9. And when I take the square root of a fraction, I do it to the top, I do it to the bottom. Square root of 25 is 5, square root of 9 is 3. Notice I'm not putting any plus minuses on this because the plus minus is when you're solving an equation. When you yourself take a square root and you create a square root to solve it. Here we're already given a square root, so we don't need to worry about that plus minus. Okay, 20 over 8. So again, one fraction, we can reduce our fraction first. So 20 and 8 can both be divided by 4. So 20 divided by 4 is 5. 8 divided by 4 is 2. So when I take the square root of this, I have the square root of 5 over the square root of 2. This right here is a problem. And the reason that this is a problem is kind of a weird little what's happening here. Back before we had calculators, finding out what the square root of 5 is, there literally were tables that they looked at, and they would look it up and be like, the square root of 5 is this decimal, because they would go through and do all the math and take, okay, what's 1 times 1? What's 1.5 times 1.5? 1.6 times 1.6, and they would do all that math. So if you were doing calculations by hand, having this square root on the bottom would cause some issues because it's a lot harder to divide by really weird decimals, because the square root of 2 is a really weird decimal, rather than going about it another way. So this process right here is the process we are going to be looking at today. And what that is we don't want to have a radical in the bottom, so that is called rationalizing. So just kind of keep that in mind. This is not considered simplified. We're going to come back to this one, but we're getting at how do you divide. So the next one, when you divide, it doesn't matter what sort of fraction, or sorry, what kind of radical you have. You can just divide the numbers. You can reduce the fraction. So this one, we get the third root of 135. When we look at our list of x to the third, 135 is not on there. So we start dividing. So we do 135 divided by 125 divided by 64. We get a decimal. 135 divided by 27. Hey, we get a whole number. So we reduce our radical. 135 is 27 times 5. When this 27 comes out, we look on our sheet, the cubed root of 27 is 3, and then we still have 3 root 5 left over. So today we are focusing on the issue that happens in the third problem, square root of 5 over square root of 2. This is not considered fully simplified. So what we're going to do is we're going to go through a process called rationalize the denominator. And what that means is we are going to change this fraction so we no longer have a radical in the denominator. And the thing is we need to make this number be a perfect square so we can actually take the square root of it. So we can't take the square root of 2. But what number could we multiply the square root of 2 by to make it a perfect square? Well, if I multiply it by the square root of 2, the square root of 2 times the square root of 2 is the square root of 4. That's something we can actually take the square root of. Up top, in a fraction, if you multiply the bottom by something, you also have to multiply the top by it. So these are both under a radical. So root 5 times root 2 is the square root of 10. The square root of 4 on the bottom reduces to a 2. Up top, do any perfect squares go into 10? Nope, 4 doesn't, 9 doesn't, so it just stays as 10 root 2. So decimal-wise, these two answers are the exact same. The square root of 10 over 2 is considered better simplified because it doesn't have that radical in the denominator. So what we're going to go through today is when we are dividing, how do we get it so that we do not have a denominator with a radical in it? That process is called rationalizing the denominator. The reason it comes up is when we divide some of these, so 9 can't be divided by 2. So we have the square root of 9 over the square root of 2. We can't reduce our fraction, so now let's jump here. Okay, so the square root of 9 is 3. Square root of 2, we can't take the square root of 2. So what we need to do is we need to think about what could I multiply by to make it be a perfect square? Well, I could multiply by the square root of 2. If you ever take a square root by itself, it's going to end up being a perfect square because 2 times 2, by definition, is a perfect square. Whatever you do to the bottom, you have to do to the top. So up top, the 3 and the square root of 2 are not the same type of number. 3 is outside, 2 is inside. On the bottom, those two are both perfect square, are both under a radical, so they can be multiplied together. Can't reduce the square root of 2, so that is stuck up there. Square root of 4 is 2 on the bottom. So the idea of multiplying by the radical, do you see how what it kind of ends up doing is the radical was on the bottom and now it got moved up top? So there's a pattern here. You're definitely going to notice it. So just know, like, you have to multiply the bottom so that it's a perfect square so that you can take the square root of it. The way it gets a little bit weird is what if we had like a binomial on the bottom? For a binomial, we need it to be a perfect square, but if we just multiply by the square root of 3, it's just going to move over to the 5. Like 5 root 3 plus the square root of 9, that's not very helpful. So instead, we need to multiply by the conjugate, because when you multiply by conjugates, the square roots go away. Reminder, conjugate just means that the sign changes. So like a minus the square root of b, its conjugate would be a plus the square root of b. Negative a plus the square root of b, its conjugate would be negative a minus the square root of b. So the only part that changes signs is the radical portion, not the other part. So to divide this problem, the real issue is you can't have a radical in the denominator. So to undo that, we're going to have to multiply by its conjugate. Just like when we had the I stuff, we multiplied by like the conjugate of the I. Whatever we do to the bottom, we have to do to the top. Difference here is now it's a square root instead of an I. I like to separate these, so up top, I'm just going to multiply a 1. I have to distribute it in 1 times 1, 1 root 3. When I multiply the bottom, now we're going to have to FOIL it. So 5 times 5 is 25, minus 5 root 3, plus 5 root 3. So remember, inside radicals don't work with outside radicals. When you do the last one, we have a negative. They're both under the radical, so the 3's can multiply together. Negative 5 root 3, positive 5 root 3 cancels. Minus the square root of 9. The square root of 9 is just 3. So when we multiply all that out on the bottom, our bottom is just going to be 22. So after multiplying them separately, we just come back and we put on our new top over our new bottom. Done. No more radical in the denominator. If you want to split it, you can. We don't really need to. Okay, next one. So again, to do this division, the real issue is we can't have this radical in the bottom. So to undo this dividing, we're going to multiply by the conjugate, because we can't really divide with the radical. So the process is going to be multiply by the conjugate. 6 minus root 2, conjugate is 6 plus root 2. Whatever we do to the bottom, we also have to do to the top. So up top, when I multiply these together, you multiply it in, you multiply it in. Since the 3 is not under the radical, it can't multiply with the 2 to make a 6. when we multiply the bottom together, here's where you get to do your full foiling because they both have a plus or a minus sign. So 36 plus the 6 and the 2 can't multiply together, minus the 6 and the 2 can't multiply together. Here the root 2's are both under the radical, so they can multiply together. Every time you do this, when you multiply by the conjugate, the inner portion should cancel, and then you should be left with a perfect square, minus the square root of 4. The square root of 4 is just 2. So our bottom is just 34. So putting on our new top, putting on our new bottom. Last thing you would want to check is if the three things outside of the radical can be reduced, you should reduce them. Nothing divides 18, 3, and 34, so we're just done right there. Okay, next one. We have root 7 minus root 3. Its conjugate is going to be root 7 plus root 3. Whatever we do to the bottom, we have to do to the top. So when I multiply the top, this one, be a little bit careful because now we have more square roots. So anything that's underneath a radical can work together. So root 7 times root 5 is root 35. Root 7 times root 3 is root 15. Check, does anything go into it? So if I look at my list of perfect squares, 4 doesn't go into 35, 9 doesn't, 16 doesn't, 25 doesn't, 36 is too big. Same thing for 15, like 4 and 9 don't go into 15. So that's all we got there. When we do the bottom, make sure you do a full FOIL. So root 7 times root 7, they are both square roots, so they can multiply together. Root 7 times root 3, they're both underneath the square root, so they can multiply together. Root 7 times root 3, they're both underneath the square root, so they can multiply together. Root 3 times root 3, they are both under the square root, so they can multiply together. Even here, we have plus root 21 minus root 21, so those cancel. The square root of 49 is 7, square root of 9 is 3. 7 minus 3 is 4. So notice how our denominator always goes away, so there's no more radical. So root 35 plus the square root of 15 all over 4. Nothing can be reduced there, so you're just done right here. So when you guys see a fraction with a radical on the bottom, the real goal is to get rid of that radical on the bottom. You do it by multiplying through. One thing, and I'm going to mention this, and it's probably, it might confuse you, might not confuse you. It's going to be this problem right here. So by definition, what we should do is multiply by the conjugate. So technically, if this is a positive square root of 2, we should multiply by negative square root of 2. So negative and the 3, root 2. The negative is in front, root 2 times root 2 is square root of 4. The reason we don't need to change the conjugate here and like make it a different sign like we do the other 3 is if you have a negative on top and bottom, they're just going to cancel away. So the real thing about like changing it to the other sign is when you have a plus or a minus sign. If you just have a single radical in the bottom without a plus or minus sign, you can just multiply it by itself. It's going to end up being the same thing because your radicals would cancel away anyway. We're going to add in some more, so just find a blank space for these, just so that we can get some more practice. So if I have like 7 over root 3. 7 and root 3, we can't reduce this. The 7 is outside, the 3 is inside. So the issue is the root 3 on the bottom. 3 is not a perfect square. But what number could we times root 3 by to make it a perfect square? Well, 9. 9 is a perfect square. So if I take my bottom times root 3, I also have to do the top times root 3. 7 is outside, 3 is inside. 3's are both inside, so they can multiply. The square root of 3 over the square root of 3. The square root of 9 is 3. Number is outside, the 7 and 3 don't reduce, so we're just done right there. If this changes though to now where it's 12 over root 3, so we still need to multiply by the conjugate. So root 3 can multiply by root 3. 12 root 3, square root of 3 times the square root of 3 is the square root of 9. So the way that these get weird is that like all the stuff you guys already know comes into play. If numbers outside the radical can reduce, you should reduce them. 12 divided by 3 is 4. that 3 is stuck inside the radical, so it can't reduce with other things. So when you guys are going through, you still need to check for fractions, you still need to check for all that good stuff. If I had like 10 root 2 over the square root of 8. Okay, so 8 is not a perfect square. Lots of different ways you could solve these. I personally will always just multiply by that square root. You don't need to think about it. Square root of 8 times the square root of 8 is the square root of 64. Up top, the 10 is outside. These numbers are both inside, so they can multiply together. So process-wise, the main thing is you multiply both top and bottom by whatever you have in the denominator. Because if you do that with a square root, the square root of 64 is 8. 10. By chance, hey, what's the square root of 16? It's 4. So it's kind of weird because like these problems can take a lot of little twists and turns, which is why these couple units are kind of, not units, topics are a little bit confusing because there's a lot of little steps that can lead you to the same thing. Because now when I do 10 times 4 is 40, what's 40 divided by 8? It's 5. So trust yourself, go one step at a time, and regardless of how like nasty something looks, the square root of 45, weird number. I don't know what it is, but I know that if I take a square root times itself, it's always just going to follow this pattern. Because if I go back, notice the square root of 3 times the square root of 3 turned into a 3. Square root of 3 times the square root of 3 turned into a 3. Square root of 8 times the square root of 8 turned into an 8. So whenever you take a square root times itself, square root of 45 times the square root of 45, at the end of the day, it's just going to be 45. If you want to figure out what 45 squared is, 45 times 45 is the square root of 25. Take the square root of that number, you get back to 45. Take the shortcut. Square root of 45 times the square root of 45 is 45. And then up top, the 7 and the 45 can't multiply. Every step along the way, you just need to see, can we do more? 45 is not a perfect square. However, what perfect square goes into 45? 9 times 5. When that 9 comes out, what's the square root of 9? It's a 3. We already have a 7 out there, so those are going to multiply. The square root of 5 is left over. 45 is on the bottom. Every little step along the way, you just have to see, okay, can I do more? Now I have things that are not under the radical. Is there any number that divides 21 and 45? 3 does. So divide by 3, divide by 3, 7 root 5 over 15. So the thing about radical rules is that they get so detailed in the sense of like, how do I solve this problem, that sometimes we get lost in the little steps, and that's where we just need to keep practicing them. Last one, now we have a plus sign. So as soon as you have more than one chunk on the bottom, we can't just multiply by the square root of 3, because when you distribute, you're not going to get rid of your radical. So instead, we have to multiply by the conjugate. So if this is a plus, it's going to turn to a minus. Whatever you do to the bottom, you have to do to the top. Up top, when I multiply that negative 6 in, we get negative 12 plus 6 root 3. The 6 and the 3 can't multiply together because the 3 is stuck inside the radical. On the bottom, we're going to do our full FOIL here. 4 minus 2 root 3, again, inside, outside, can't go together, plus 2 root 3. Now these ones are both inside, so 3 times 3 gives us a 9. Our middles should always cancel. The square root of 3, or sorry, the square root of 9 is 3. 4 minus 3 is 1. So our new top, negative 12 plus 6 root 3. Our new bottom is a 1. Do we need to write 1s on the bottom? No. So as we go through yesterday's assignment, just know it's a lot of little steps. And we just got to keep following the processes we know work until we kind of get it to a part where we can't do anymore. Thank you for watching. Your assignment is posted on the calendar. Use your own paper. Bye.